Discover Geography, Lesson 3-2, Glacial Landforms. In this lesson, we're going to be talking about the effects of glaciers on our landscapes. A glacier is an enormously thick sheet of ice that lays across the land. There are two basic types of glaciers. We have continental ice sheets, which cover vast areas of land, and there are alpine glaciers, which are like rivers of ice that flow through high mountain ranges. In this lesson, we're going to focus on the effects of continental ice sheets, and we'll leave alpine glaciers to another time. Currently on our world, there are two major continental ice sheets, one covering Greenland and one covering Antarctica. But a few thousand years ago, continental ice sheets extended much farther from the poles. You can see here on this map showing the last glacial maximum, which was the last point at which glaciers reached their maximum extent over the Earth, which happened about 18,000 years ago. You can see that nearly all of Canada and the northern slice of the lower 48 states were covered in ice, as was northern Europe and some parts of Siberia. Here in Pennsylvania, the glaciers came down into the northwest and northeastern corners of the state. So everywhere that you see color, those are areas that have glacial landforms in them in the state of Pennsylvania. The advance of those glaciers was not a one-time event. In fact, we have several cycles of glacial advance and retreat within recent geological history. So what you see here is a reconstruction of past temperatures. So every time that graph goes below the center line, that indicates a glacial phase, when glaciers would advance out away from the poles and cover more land. Every time the graph goes above that center line is what we call an interglacial phase, where the glaciers retreat and give up the land. And so you can see there's been a whole series of advances and retreats of glaciers that are driven by a wobble in the Earth's axis that leads to cooling and warming of the global climate. If you look to the far right side of that graph, that is the present day. This graph runs from far back in history on the left up through the present day on the right. That Holocene interglacial, that's everything since that last glacial maximum, that's since the retreat of the glaciers that began 18,000 years ago. All of recorded human history exists within that Holocene interglacial. The beginnings of writing, the beginnings of farming, the beginnings of urban life for all of humanity did not begin until in that last little time since the glaciers have retreated. Now, our species has been around for about 250,000 years, our current Homo sapiens species. So we've lived through several glacial and interglacial cycles as a species, and then of course our ancestors lived through even more of these cycles. But everything we think of as human civilization has really existed only within that last little bit of an interglacial period that we are currently in. Glaciers begin with a process called accumulation. A glacier is formed when snow falls during the winter and doesn't melt all the way during the summer. So in most places we're used to snow falls in the winter and then it melts away during the summer. So by the time winter comes around again, the ground is free of snow until new snow starts to fall. If snow made it all the way through the year to the next winter, so that then more snow would fall on top of it, we would have a process of accumulation. We'd build up more and more snow on the ground every year. And the weight of that snow would compress the bottom layers until they hardened into ice. This is the process by which glaciers are formed. There's a zone of accumulation where snow falls during the winter and does not entirely melt away during the summer that builds up more and more ice. As that ice builds up, the weight of the new accumulation starts to push the old ice outward, starts to push it away from the center of that zone of accumulation. And so now the glacier begins to advance. The glacial ice begins to scrape forward across the land. As that ice scrapes forward, it's going to erode the land surface under it. The ice is going to dig at the ground. it's going to grab pieces of rock and dirt. They're going to freeze into the bottom of the glacier. And so it's going to be like sandpaper scraping across the ground. All of this sediment that the glacier scrapes up, all of this material that the glacier scoops off the ground, is known as glacial till. And you can see some till in the picture there. It's this mass of rocks and dirt and sand that have been scraped up by the glacier and pushed along until the glacier deposits it somewhere. So if we've got a zone of accumulation, we've got this glacial ice pushing forward out of the zone of accumulation, scraping across the ground, eventually the glacier is going to start to experience ablation. Ablation is a process of melting of the glacier. The glacial ice will get pushed into an area that's warm enough that it's going to start melting away. The advance and retreat of glaciers is based on the balance between accumulation and ablation. So when that ablation is happening at a high level, the glacier starts to melt away. And so the front of the glacier melts back, and so the glacier covers less and less land, and that's called glacial retreat. In both cases, whether the glacier is advancing or retreating, the ice within the glacier is always moving forward. The ice always moves from the zone of accumulation towards the zone of ablation. When the accumulation is higher than the ablation for the glacier as a whole, the glacier is going to advance. The end point of that glacier is going to get farther and farther out every year, as that ice can make it farther every year before it finally all melts away. When the accumulation is less than the ablation, the glacier is retreating. That does not mean the ice has turned around and gone home. The ice is still moving forward from the zone of accumulation towards the zone of ablation, but it doesn't get as far each year before it melts away. So when the glacier is retreating, the ice is moving forward, but it's just not making it as far as it did before it finally melts away. Glaciers will construct a variety of landforms on the land. One thing that they might create are what are called glacial erratics. A glacial erratic is essentially a big out-of-place rock. So if there's a giant rock that's just kind of sitting there, and it's not related to the other rock around it, we may be dealing with a glacial erratic. Essentially that means that the glacier picked up that rock somewhere along the way, froze around it, dragged it along, but eventually the glacier melted, and so it just dropped the rock. Glaciers always push that till forward. They always push things forward until they finally melt and leave it behind. So that erratic was dragged forward by that glacier for a while. When the glacier finally melted away, it left it there. Another glacial landform that we might see is gouging. So as the glacier moves, it's going to scrape the land underneath it. And sometimes it'll hit a weak spot in the underlying ground. And so it will scoop out a big hole. And that's known as glacial gouging. So a good example of that is the Finger Lakes in New York State. As the glaciers moved southward out of Canada, they scooped out these long valleys as they went. They then filled with water when the glacier melted, and were left with these long, narrow, scooped out holes from the glaciers. Another glacial landform is known as a moraine. A moraine is a long ridge made out of till that shows where the edge of a glacier used to be. So as the glacier is moving forward, as the ice is going, it's going to scrape up all of this till. And it's eventually going to dump it out the front end of the glacier or out the sides of the glacier. As that ice gets to the end and finally melts away, it's going to dump all that till it's been dragging along. So if the end of the glacier stays in the same place for a while, it's going to start to build up a pile of till, kind of like a bulldozer that keeps driving forward to the exact same spot will build up a pile of material that it scraped up. It's essentially what the glacier is doing. And so it'll form this long ridge that will be perpendicular to the direction of motion of the glacier. So if the glacier was moving from north to south, it'll pile up a moraine that runs roughly east to west. And it may create a series of these as it retreats. If the glacier retreats and then pauses in its retreat for a bit, it'll pile up another moraine. If it retreats some more and then pauses a bit, and it'll pile up another moraine behind that, etc. Here's another moraine with some trees growing on it, so it's a little less distinct to see here. And here it is on a topographic map. You can see that ridge running kind of east-west through the center of this map. It's broken in one spot by a big stream that's eroded through it. But you can see the general tendency of that east to west ridge. That's a giant pile of till that was built up by a glacier. Another glacial landform is known as a drumlin. A drumlin is a teardrop-shaped hill. The interior of that hill is made out of till. So it's a pile of till, kind of like a moraine. But instead of one long ridge like a moraine, drumlins are individual teardrop-shaped hills that usually occur in clusters. So you can see a whole cluster of drumlins on this particular map. Drumlins are oriented in line with the movement of that glacier. So the glacier in this particular location was going from northwest towards the southeast. And so you can see that those drumlins are aligned in that direction. The point of the teardrop is pointing in the direction that the glacier was moving. So the point of the teardrop of all of those little hills that you see here is pointing to the southeast. Another glacial landform is a kettle. A kettle is a round pond or small lake. A kettle is formed when a giant chunk of ice falls off the front end of a glacier and gets till piled up around it. So we have a big chunk of ice sitting in front of the glacier and it's getting buried in till. Eventually, that big chunk of ice is going to melt. But while it was ice, it created this gap in the till. So when it melts, it's going to leave behind a little hole, a little pond that has been created there with a bank made out of till around it. And there you see an example. We saw this particular map in one of the earlier lessons. Lake LaBeouf in Pennsylvania. This nice little round pond was formed by a big chunk of ice sitting there and then till piling up around it when the glaciers were in this area. One last thing that glaciers can do is they can rearrange the course of streams. And so that's what you see here. If you watch the little animation and compare that to the map on the left, the map on the left shows the direction of the various streams in the area around Slippery Rock before the last glacial advance. So at that point in time, Slippery Rock Creek and several of the other streams in the area actually ran northward into Canada. And it was only somewhere south of Slippery Rock, sort of south of where Portersville is now, that the streams ran southward towards the Mississippi River and towards the Gulf of Mexico. Of course, today, Slippery Rock Creek heads southward towards the Gulf of Mexico as well. This is because when the glacier advanced, it blocked the drainage of those northward flowing streams. They could no longer flow out through Canada into the Arctic Ocean. And so initially, they built up giant lakes at the front of the glacier. The stream would flow in towards the glacier, it would get blocked there, and would form a big lake. So Lake Edmund was the big one near Slippery Rock. As the glacier started to retreat, these lakes got big enough between the inflow from the streams and the meltwater from the glaciers that they burst their banks. And that water rushing out of these lakes carved out a new channel headed southward. So Slippery Rock Gorge was formed by this glacial meltwater bursting out of these lakes and carving a new path southward. And this is why, if you look at a map of the United States, you'll see that in the lower 48 states, we have hardly any rivers that flow northward into Canada, because any rivers that used to do that got blocked by the glaciers during the last ice age, and most of them carved new southward channels in order to find a way to drain out of those lakes.